All right, so I'm completely back in business now. I tested my audio. It's a lot better, hopefully, because I picked up these things I used to have. I guess I could have been, I think like I had some Bluetooth headphones before and I tried the audio on it and um, it wasn't super good, but these are new and I think the audio is a bit better on these. So I'll be wearing headphones during most of these, so please prepare yourselves. Do not panic. I'm just wearing headphones. That's the only difference. Besides the audio quality being better, that'll be, but that's a good thing too. Okay, so last video we looked at
Yeah.
the oh, that was really loud. We looked at the uh, Cisco campus LAN and wireless LAN design guide, and where we ended was learning about the stacking topology. So, right, and this is not entirely true. The next video is not going to be um, the well. Let's take a look at the lab because I'm not sure if I set up the layer three topology yet or not. I think I did, but we're going to start this video off by going and reviewing that. Yeah, so the reason I thought that there was still some work needed to do on one of the legacy designs is because in the last video we actually and forgive me, it was over a week ago. I was just on a working trip, so yeah, and I shut down my lab while I was out of my apartment. But these Arubas are actually capable of higher link speeds than these extremes. These lab versions of the extremes that came with GNS are only capable of 100 gig all around. So we can't use these in the distribution because especially here if we want to use our 1 gig ports, it's just not going to work because our oversubscription ratios just would not be practical. So what we can do though is use these extremes in the access layer, but even then, actually, we're going to have some problems because on these extremes, there aren't any ports that are capable of 1 gig. So our oversubscription ratios are going to be as such. So it's going to so each port that we have is going to be a 100 meg port, or sorry, yeah, 100 megabits per second, and then our uplink we can only use a 100 megabit per second as well. So that makes things um, a little bit limited. But the good news with that is since we're dealing with the same values for the uplinks and the handoffs, calculating our ratios is really easy. To get a 20 to 1 ratio, that means that we can only use 20 ports. And it looks like we don't even have 20 ports available. The maximum amount of ports we can use in our topology is going to be 10 ports because we're going to have two of those ports being used for the uplink. So that counts as the denominator. Um, and then we have ports handing off. We only have 10 of those. That's the numerator. So since we have 10 100 megabit ports that can be used for edge switches and two that can be used for uplink switches, we have an oversubscription ratio of 5, which is really good. You can even use that potentially in the connections between the access and the distribution layers, which is where you want those lower oversubscription rates. If we had a 10 to 1, that would be perfectly fine as well. And we would get that if we used the legacy layer 2 design, because we would have one of these blocked by spanning tree and only one of those links available. We have redundancy, but redundancy is quite a bit different than bandwidth, unless you're using what we just saw, uh, the design where it's a hybrid of layer 2 and layer 3. You have a layer 2 links here, and then you have a layer 3 link here. You can use VRRP. You saw you had load balancing there, as long as you used different default gateways here for the different virtual IPs. So in that case, since we're using both of these links equally and we're load balancing, we've got that oversubscription ratio being 5 to 1, which is really nice. So let's put that somewhere as a note. So the oversubscription ratio is going to be on these links here, and it's going to be 5 to 1. Oh, and that's good. That's the oversubscription ratio once we move these down to the edge. That's what I was trying to get at, is the fact that these extremes are better suited for the edge than the Arubas are. They're going to be much better for the distribution layer because they have higher links available. They have 1 gig links as well as 100 meg. And once we get to this next section, which is on stacking, it's much easier to stack these Arubas than it will be for these extremes, as far as I know. Maybe it's easy to stack the extremes, but we'll find out. That's the point of the video. All right, so here is the Cisco software designed Access campus design. We're going to be moving on to that, but first we're going to be labbing. We're going to try to set up this simplified solution with a VLAN per access switch. After that, we'll do a simplified distribution design with VLAN's spanning access switches, but you don't need spanning tree because this is operating as one, as if it were one device. Now, what I would recommend in this case is setting up, and even this case as well, setting up spanning tree regardless, because even if spanning tree just sits there configured and doesn't do anything, the moment you have a misconfiguration where there is a loop, spanning tree will just kick in and kind of uh, save yourself from potentially losing remote access or something like that. So let's verify this here. It's been a week, so I kind of it's not fresh on my mind whether or not I set this up. So we're going to start by verifying that. So let's hop on the extreme. Okay, and then we'll do a show IP route or a show route, whatever the command happens to be. Show. So here's the layer 2 MAC address table. We want to see a routing table, so it's going to be perhaps a bit more challenging to look at than I had thought. Okay, so I guess we're gonna have to go right to Google on this. Extreme OS show route. Okay, so I think I found it. It's show IP route. Perfect. So let's see what kind of networks we have here. Um, in the routing table, uh, so we've got some 10 dots here. Ah, perfect. So that's what we used for the PCs. Then we've got one, two, three, four, five of these networks here. And I'm using /30s. You can also use /31s on a lot of devices. Um, if they support that, there are some end devices or something that might not support that. There's an RFC for /31s. So it's RFC 3021. That is what describes using a /31 because usually because how would you take in a prefix to the table? Lots of things, security concerns. Um, so maybe that's for another video to read that. But let's ping from PC1 to PC2. And then I think that will be the end um, of verifying that everything is good. Another thing I can do is shut down devices and see how it fails over. Now it should fail over just simply because of the routing protocol. Oops, let's take a look at what's on here. Okay, oh, yep, so, oh, how does that work? Oh, I see. That's how it works. These are the ones off of the same VLAN interface here, the same subnet. Let's take a look at. So I mean that right off the bat is a bit concerning. It should be able to ping that one. Yeah, so we're gonna need to troubleshoot that. Okay, so but let's see if I can ping all the way across to the other side. Oh, you know what? It almost looks like I misconfigured because it may seem more yeah, so it looks like I misconfigured the end devices. This one doesn't have configuration on it. So let's make it easy on me here. We're gonna get rid of this link, get rid of this link, and then we're gonna flip these around here because this one is configured correctly. But then, or sorry, this, yeah, but this one is gonna require some configuration. So we'll add that. Okay, so we're going to need to use a different network on here, and it's going to need to come from what's configured on here. So let's take a look at that. Okay, so it looks like we've got a VLAN 100 that is set up. Now I don't see it trunked over any of the ports. Okay, I do see it over there. So yeah, so this has got to be configured for VLAN 100. Let's do that. You know what? I might have forgotten the save command on these, and it might have lost its config because of that. So let's do IP, and then we'll do 10.0.1. Or .2, and we'll do 254. Or let's do 100 slash, and then we'll do 255 0, and then we want a gateway. All right, and then I'll make sure that I do save. All right, so let's configure the other two now. Okay, and likewise, we'll need to go on the Aruba and make sure that we're configuring it in the correct subnet. Okay, so this one has .1. Let's take a look at the port config. Looks good. Okay, we can't do that. That's a duplicate. All right, but that one looks good. So this does have a process to check for duplicates. That's something I checked before. So that must have been due to the ARP. Or actually, I'm not sure what happened there, but we've got it saved. So final step we're going to do, because we're just verifying the last design before we move on to a new one, is ping across all these. Once we can do that, we're good to go. Okay, so we got a reply from 101. Let's see if we have a reply from PC3. All right, and we've got a reply from PC3. So here's a interesting knowledge check. So let's take a look at the MAC address on PC3. So yes or no, will we see this MAC address showing up on these two PCs? A ping was successful. You need a MAC address in order to ping. So yes or no, is that going to be in there? 3, 2, 1. The answer is no. It's not going to be in the ARP table. So let's take a look at that. We can see we've got a different MAC in the table. 0, 1 and 0, 0 is the MAC that was on PC3. So let's do another knowledge check. Where did this MAC come from if it didn't come from PC3? 3, 2, 1. The MAC address came from the default gateway, because when you're pinging a device outside of your own subnet, you need to go through a default gateway that is either configured on the device or that is allocated to the device through a method like DHCP. All right, so let's take a look at which MAC address is on VLAN 100 here. Oh, okay. This isn't the one that we pinged PC3 from. So this only has one entry in its ARP. It didn't need to go through the default gateway. But this one here is going to have multiple entries. Um, uh, yeah, one for the device in its network, which is going to match the MAC address on the actual end host. But one kind of mystery MAC that doesn't match any of the MACs, doesn't match the MAC on the host that was pinged here. And why is that? It's because the host is on a different subnet. So this MAC here, we'll see, is going to match the MAC on the default gateway because it sends traffic that it doesn't know how to leave its layer 2 broadcast domain out to the default gateway. All right, so let's tear it down and build the whole thing back up. So I'll just take apart all of the links because the first thing we're gonna do is change the um, distribution and access layers, the equipment that is used for each of those. We're gonna use Arubas in the distribution, and we're gonna use extremes in the access. All right, so the first thing I'll do is sever these links here because these are not plugging in to the Arubas anymore because the Arubas are at the distribution layer. So end hosts like these PCs are going to plug into the access layer. The next thing I'll do is move these Arubas up and move these extremes down, and then move these over. Last thing I'll do is sever this link here because the access layer does not have links between it. That's what the distribution layer is for, so that you don't need to daisy chain those links together. So I'll use the highest port, which on the device is going to be 118. Now what I can do, I think, is change how that looks. Okay, I'm not exactly sure how though. Oh, here we go. This is what I can do. Yeah, I think I can do it by changing this. Yeah, here we go. So the first port, let's pull it up. We're going to change the naming on these so that it actually matches what we see on the device. So let's do a show in status, or sorry, it's brief, show interface brief. Okay, and now we've got 111 through 119, which matches what we see here, 111, 119. But we can see if we were to shut down for example, 112 here. Um, so let's start the capture, and then we'll sniff the link, and we'll see if the traffic actually stops once we shut down 112. So we've got OSPF hello packets, we've got extreme. Um, so let's get an eighth packet here. There we go. We got 8 and 9. Let's shut this down. We got 10. Um, so now let's see if we continue to get traffic. So let's see if we get a 15. And we do. We get 15 and 16. So that's proof that it's actually not true that this is 112 uh, because we tried to shut down the link, but we can see we still got traffic. So let's see what happens. I'm going to bring this back up, and let's see what happens if we shut down interface 111 instead. Okay, so we've got packet 34, 35, 30, 41. Okay, so we've still got plenty of packets coming in. Um, hmm. Now we've only got one source address. Before we had two. So, I mean, I expected it just to not be working at all now because I thought it would bring the line protocol down. But it looks like with virtualization, it still allows that other side to stay up. So let's no shut it and see if we get traffic coming back with a source of .10. Here we go, right away, instantly. We get .10 sourced traffic. So we know that actually 111 is what is meant by 112. All right, so let's make the proper adjustment. And we can see here, um, if we click on the network tab, we've actually got port 2 is the name format. So let's change that to port 1. There we go. First port name looks good. So we're going to do OK, apply, OK. And now the ones that are already out there, I don't think we'll see a change. It only applies to newly created ones. So let's create a new one. There we go. Start it up. Perfect. And let's see how it's different. So one of the differences here is that we've got two ports now that are named 111. So let's find out let's take a look at, yeah, you know what? I think let's have the management port be the first 111, and then the second one will be the actual 111. So we'll go back to QEMU, VMs, we'll go to Aruba, and then we'll do MGMT for the first one. Apply, OK, make a new one. All right, and we don't even need to start it up. Let's just see what's on there. Okay, perfect. So now we've got the management port and we've got ports 1 through 8. That's exactly what we're looking for. So now when we configure port 111 here, we'll be configuring port 111 there as well. Okay, so we can get rid of these. Okay, and let's give this a better host name. We're going to call it dist L, and let's do it all in uppercase. And I'm not sure if, so dist-l looks good to me. Do one more, we'll call it dist-r. All right, and then let's plug these in. We're going to plug it in port 5 to port 5. We're going to start it up, and then we're going to see what happens to the traffic on the link when I actually shut down 115. With the correction that I made, it should stop the capture. Now we're going to need to put some simple config on here. We're going to need to put a routed interface on each of these. So let's do that right now. See if I can get the right one up as well. Okay, and we'll do some basic configuration on here. First thing we'll do is change the hostname. We'll do that. Oops, I'm on the wrong one. Perfect. Next thing we'll do is set up a routed interface. Okay, and we'll put an IP on it. And no shut it. And the final thing we'll do is save it. And already we can see we don't have to make the port go down because we were already sending source traffic, even though we configured interface 111 here. Now it matches, it's not off by one with what is here. So already there, we've got enough of a proof that I think I'm gonna stop. So I'm gonna sever this link now. I'm going to default the interface 115. And write, of course, write mem, of course. And now I'm going to plan out my links. So, and I'll write down my oversubscription ratios as well. So the next part of the Cisco design guide Okay, so now we're gonna be stacking these. So let's um, yeah. So here with Cisco devices, we're using Cisco Stackwise Virtual Pair. Let's go to the Aruba documentation and see how we can stack Arubas. So we'll type in stacking Arubas, Aruba switches. Okay, and then let's take a look at what we're actually working with here. So we'll do a show version. So we're working with Aruba OSCX. We'll do stacking. Okay, so we've got some guides here. Let's see what we got. Yep, so we want to, that's similar to what we're doing here. Ideally, I'd like something written down here, but we can go to YouTube. Might want to switch away from these Arubas actually and use the Cumulus. Okay, so it looks like we've got something called VSF. Um, let's see if that's going to work. So I'd like to close this plane, please. I can't. That has to remain open. So let's just expand this up. All right, I think I'm gonna take a break here. I just need a break. We'll keep looking into stacking. I might want to switch this out for a Cumulus device. Let's type in Cumulus stack. All right, let's just see what we got on the command line actually. So we'll do the command stack or show stack. Nothing. Okay, let's see if we've got a command stack. Maybe system or maybe switch. Anything about stacking? I see tracking. Service stack maybe? Hmm. So let's continue for Aruba. Yep. Keep looking into this. Now we did read about VSF. I don't see that anywhere on here though. All right, this looks interesting. Here's something called VSX, Virtual Switching Extension. Okay, so this looks like what we need here. VSX is going to collapse these down into one device. Perfect. So we got a step-by-step guide here. Um, so let's look for step number one here. So step number one is to create a leg interface. All right, what's step two? I'm just curious. Step two is to set up the keep alive link. And then what's step three? All right, I don't see a step three. So it looks like it's going to be as simple as 1, 2. So, okay, so the first thing we're going to need to do is uh, set up a leg interface for interswitch link. So we can see we've got 2 ports in the leg. Let's go with that as well. Looks like we're gonna want to pick the fastest link speeds that we have available. So let's first set up our 2 links here. And we'll set it up on 117 and 118. All right, and then we'll go with what they have here. So 256. You know what? Let's just paste the whole thing in. Oh, and as I said, I do need a break here. So let's just get the stack up. We're gonna go interface 1, 1. Oh, actually, we're creating a leg interface, so we don't need to specify one. Let's see what the highest number is available for a leg. Oh, it looks like 256 is the highest. So yeah, let's go with that. Here we go. And now we've got our leg on the left side. Let's set it up on the right side as well before going on. Next step is going to be to add ports to the leg. It looks like there's no difference between the right and left sides of the configuration. All right, so that was really easy. Next step will be to add or assign the physical ports. So we're going with port 7 and port 8. So let's grab this, put it in Notepad, and change it up. go. Okay. All right. So now let's take a look at our leg. Before we do that, though, we'll save the configuration. All right, and then we'll take a look at our leg. So, yep, we've got our two. Aha, so this is what I wanted to see. It looks like we've got 2 gigs for our leg there. That's better than I thought we would get. Um, and that's because we've got 2 ports in our leg, so that those can be added together to form a 2 gig link, even though both of the links are only capable of 1 gig. All right, so next step, under the configuration mode, go into the VSX context by entering VSX and issue the following commands on both switches. Okay, so we've got a difference here. We've got one side being the primary, the other side being the secondary, but we can still just paste everything in. We'll have the left side be the primary and the right side be the secondary. Oops, I gotta be in configure mode. All right, so it's looks like we got a verification command. So as always, we'll do a right man before doing the verification command. All right, and then it's going to be show VSX status. And there we go. We've got each of our system Macs. We've got the platform. We're using a virtual platform. We've got, yep, so we see virtual there. We've got the software version, and we've got primary and secondary showing up correct. So it looks like all of our configuration was correct. We'll see things flipped. We'll see the 7B over on the peer side, the primary over the peer side, once we take a look at the same command on the other device. Okay, so we've got the same command here, and the local is now primary, and the 7B is now the peer. And so the local, perfect. So next step is to set up the keep alive link. It is recommended to set up a keep alive link to avoid split brain scenarios if the ISL goes down. We are trying to prevent both switches from thinking they are the active devices creating STP loops or other issues on the network. This is not a must-have, it's a nice-to-have. As of Aruba CXOS 10.0.6, you need to sacrifice one of your data ports for this. So it's a nice to have. It costs you a data port, but what you get back from it is hours spent troubleshooting if there's a split brain scenario when the ISL goes down. So you got your network automation set up. You can identify a split brain scenario easy through what you got. Don't worry about it. But in my network here, I haven't really been focusing on that yet. So I'm going to go ahead and set this up. A few things to note is recommended using a routed port in a separate VRF for the keep alive link. You can use 1 gigabit per second link for this if it is needed, so you don't need to match the um, uh, 2 gig capacity of the main link. You can use less than that. You can just use a single link. All right, so now we're gonna do this. Let's put this in a notepad and clean it up. And for my link, I'm gonna go with um, oh, Okay, it looks like 119 is actually the management port on here, so it still doesn't exactly match what's in there, but it's matching a lot more closely now. So let's add a description. Oh, you know what? Let's not do that. Let's just full speed ahead here. What we do need to do is pick out a port for the keep alive and cable it up. So we're using 8 and 7 for the main links. So let's use 6 for the keep alive. Perfect. And we'll configure that. All right. And now on the, oops, so made a mistake here. So let's do a default interface 116. All right, and let's paste it into the correct device here, the one on the left. All right, and then we'll clean up this and apply it to the one on the right. So we've got a different IP address now. It's on the other side, and we've got 116. Now this seems like a pretty big subnet to me. I'd rather use a slash 31 for that, if possible, but we'll just go with what's in the help doc for now. I don't want to give up that much space, although oftentimes if you're just using your own private space like that, you don't really need to worry, especially since you can use network address translation or some other solution. So, yep, so we needed to define the VRF. We did that up here, and we attached it down there. Next step will be to cable up that link. All right, and then we've got another step here. Oops, and it looks like we got to go back to our VSX and add our keep alive to that. We don't have that in there yet. Let's take a look at what we got. Yep, so that's empty. Let's go and add that. Excellent. So I think that's everything. Um, so next up, looks like we've got VSX MLAG, VSX active forwarding, and VSX active gateway. But I don't see. Uh, oh, it looks like it just all came out of the guide here. So we know we're working on VSX. Let's type in VSX. Oh, this is the VSX guide. Perfect. So we're not using it in the core layer. We're using it in the distribution layer, which is often called the aggregation layer. So this is what we want, is the aggregation switches. Yep, so this looks very familiar. That's what we just did. Yeah, okay. So it looks like the next thing they want is a multi-chassis interface, and that makes sense because we're going to be following this design guide, and we can see that's exactly what is in there. If I can find it. Yeah, here it is. So now we've got, if I were to separate these out, you can see we've got a connection here to one chassis, a connection here to another. So here we have just a regular port channel, but it's quite a bit different because it's going to two different devices. So of course there needs to be a multi-chassis port channel on each of those devices. All right, so let's get our cabling set up. So we're going to do port 1 to port 1, and then port 2 to port 2. Then here we'll do the same. We'll do port 1 to port 1, and port 2 to port 2. Okay, so now we've got 3 ports left over on these. We can plug in our DNS servers, load balancers, what have you. Down here, we've got plenty of ports. We've got 10 ports left over to plug in our PCs, and that gives us uh, a 10 to 2 ratio. So 10 divided by 2 is 5. So we've got a 5 to 1 oversubscription rate, which is perfect. You can have 20 to 1. It's really 16 to 1. 5 to 1 is almost a bit much for a simple architecture like this. You can keep it simple, probably just use the simple layer 2 because your oversubscription, a 10 to 1 oversubscription ratio is totally fine. So if VSX is daunting, or if you don't want to spend the extra money on another cable, because right now we have 1, 2, 3, 4, 5, 6, 7 links. So we can do it in 5 links. Um, we can do it in 4 links actually, just by having layer 2 and spanning tree and having these 2 links blocked here. That would be totally fine. You need fewer links. Um, and in fact, something as simple as this, where we're just plugging in a few PCs, yeah, you can just have like one in the distribution because um, again, you only need that where we have such little port density on these. Your oversubscription ratios really can't really get that out of proportionate. I mean, even if you have, since we only have 12 ports, um, the most we can even do is an 11 to 1 ratio, and that's totally fine. Once you start getting out to 16, 20, then you want to make sure that your design is optimizing for that oversubscription ratio. But in something as simple as this, with such low port density, those ratios really don't warrant more complex designs. You can use a really simple, straightforward design because you don't have the risk of oversubscription. All right, so the next step we saw is, now that we've got things cabled up, is to form an MLAG connection here, and then of course port channels down here. I'm going to take a break. When I get back, we'll dive right into it. All right, I've been closing my tabs here, but I'm not done yet. So let's see if I can finish up at least this part of the video before I take a more extended break. So let me go to my history, and we were working on VSX, so we actually found the VSX guide, I believe this is it, for 10.06. And then we were working on, aha, so it looks like it's saved. Yep, it saved the place in the guide that we were working on. So next step will be enabling multi-chassis interface. with the appropriate trunks allowed, of course. But let's start by creating our interfaces. So we used 1 and 2. So we're going to be creating a multi-chassis interface to each of these. So 1 and 1 will be going here. 2 and 2 will be going here. So we'll make one called leg 1, and then we'll make one called leg 2. Okay, so let's take a look at what is required to configure this. Looks like we need a keyword here, multi-chassis. Aha, there's how you toggle the sidebar. Now I can see a lot better the instructions. So we got a no shot. Now we can have a routed chassis, routed multi-chassis leg, or non-routed. We're gonna do in accordance to the design guide here, which I believe was non-routed, but we'll double check that. Okay, I'll try to get back to my place again. Found it. So yep, it's non-routed. It's layer 2 with a VLAN. Um, Now we can make it routed. You know what? I might want to just make it routed because I don't understand why I wouldn't want it to be routed. I guess in this case here it couldn't be routed. But here there's no reason to not make it routed. But here we couldn't make it routed because we're going to use the same subnet. So let's start with this first design here, and we will actually make this routed. So we'll do routing. Oh, okay. So there's a reason enough. A multi-chassis leg cannot enable routing. So we'll do no routing. Then we'll do VLAN trunk native 1, VLAN trunk allowed, and we'll use the VLAN shown in the design guide. VLAN 30 on the left, VLAN 40 on the right. Oh, first we gotta configure VLAN 30 though. Same thing here, we gotta create VLAN 30. And we'll call it left even though it's on the right because I'll show in a minute here what it will look like. Okay, so now we've got VLAN 30 set up. Let's move on to VLAN 40. And again, this is on the left, but I will use the description right. Okay, so we've got our multi-chassis legs created, no problems there. Next step is to actually add ports to the legs. So let's take a look at what ports we have up. Okay, so we have ports 1 and 2 down right now, but of course we'll bring them up. And then from before, we saw that we have ports 1 on both of these devices plugging in here, and ports 2 plugging in there. Okay, same thing on L. Okay, and then we're going to need SVI gateways as well, switch virtual interfaces. We're not doing any IPv6, so we can leave that off of there. You see we have a active gateway, similar how we did for BRF. Got to define a MAC for it as well. Now it's only giving us one side, so I'm not sure what goes on the other side there. Is it the same MAC? Is it a different MAC? Uh, there really is no information about that, but since we know it's meant to be a virtual MAC to represent a single interface, we'll make it the same. Um, okay, perfect. So we're gonna set up VLAN 100 and VLAN 200. Oh, actually, no, we're not. We've already got our VLANs. We've got 30 and 40, so let's go with that. Okay, so we've got to define an IP address for this. We'll go .2.3, so IP address, and we'll use, 192.168.2 slash. Now let's think about what size subnet we're going to need and where this subnet extends down to. So we're using a layer 3. We're having our layer 3 boundary be on the access layer again. We're not changing anything from here where we have a layer 2, layer 3 boundary on the access layer. So basically our network is going to continue to look like this, layer 3 routed access network. But the difference is now that we only have one device here, logically, I mean, we still have two devices. we need fewer subnets. So what I'd like to do actually, if possible, is to conserve as much space as I possibly can and do a slash 31. But I'm not going to be able to do that because we have virtual IP that we're going to need to do. So I need at least three addresses, one for each of my virtual interfaces, which gives me two addresses, and then an additional address for the virtual interface. But even more than that, I need addresses for the host interface, the connecting interfaces. And in this case, we only have one, it's the access switch, but that gives me a total of four addresses. So let's go with a slash 29, because that will give us six host IPs. And it will conserve more space available for future subnets. So slash 29 is every 8. So our next slash 30, we can start at .8. If we used slash 24, we couldn't use any of that space until we did in a third octet an increment of 0 to 1. Here we can just continue to use that space that we would have had not available if we had used a slash 24. So we're going with the slash 29. Okay, and then we're doing active gateway IP, 0.1, MAC. Here we go. Okay, and then we will need Ospf as well, because we've got to learn in this boundary here, because the boundary is the SVI for the subnets for the access layer. So we need those. Those aren't directly connected routes because they're coming off of these. So we're going to need some sort of routing protocol. We'll go with Ospf. That's what the guide recommends. Now the guide is recommending Ospf version 2 for some reason. But you know what? I'm going to just stick to Ospf version 3 because as far as I understand, you can use version 3 for IPv4 addresses without using some sort of dual stack solution, but we'll put it to the test here and we'll really see if that's the case or not on Arubas. But as far as I understood, if you read the RFC for Ospf version 3, it does work for version 4 without any special kind of configuration required. Right, here's the RFC for IPv version 6, so let's yeah, so these have been updated. Let's look at the updates, but it hasn't been obsoleted. So if it hasn't been obsoleted and it's only been updated, that typically means that there are extensions to it. So like special cases where, and this is really like where, well, that's interesting. That one's really interesting because I'm all about automation. So if you can use Ospf 3 for auto configuration, that sounds great. Yeah, so I'm going to leave that tab up. I might include that in the notes here. Um, but for now, the interesting RFC is this one. Yeah, so I don't see anything about it being not possible to use for IPv4. I really, as far as I understand, believe that you can use it for IPv4 as well without special configuration. I really thought that OSPF version 3 was backwards compatible. All right, so let's go full speed ahead here. Um, yep, I've got all the commands on. One side, it looks like I'm missing it on the VLAN 40 side. So that's slash 29, so that's every 8. So we'll pick out another slash 29, starting with, we've got to configure VLAN 30 on here as well, because it's VSX. Yeah, so this is going to be .3 slash 29. Okay, and hopefully we have audio back. I apologize for that. That was really stupid. Um, I don't know how long I have been recording without audio, probably a bit, but again, I am sorry for um, really not prioritizing this channel the way, so Network Chuck, big shout out. David Bumble, big shout out. If you're watching this for professional, somebody uh, tailoring content to an audience, there you go. Network Chuck, David Bumble. They have Discords, they have YouTube channels, they have live streams. This channel, let me be clear again. This is just me practicing my skills in IT in a public way, um, to keep my skills up. And there are some things that I won't be able to do on this channel. Anything that is copyrighted, any like talking specifically about things where there's a non-disclosure agreement, talking about what I actually see in the workplace, talking about what I've actually seen on a test. So there's things that I can't do on this channel, um, but for the most part, a lot of what I do on this channel will, I believe, get me to the next level and really have me be kind of a leader in my field. So I hope this channel will be useful to anyone who is interested in that and kind of wants to see the montage, the 80s montage of somebody doing karate and then winning the tournament. This is the montage here. This is me training myself. Unfortunately, I do have to make some sacrifices to do it in public. I've got to make sure that what I'm doing is public and uh, not violating any NDAs, as I mentioned before. But this has been motivating me. It's nice to go back and kind of see how far I've came. Um, it's nice to get competent speaking and stuff. So I'm gonna keep doing these videos, but I really apologize if it's just not up to the standard of like a professional YouTuber who's like actually concerned is doing YouTube as the primary thing they're doing. And again, David Bumble, Network Chuck, those are your guys to go who are doing that. Me, I'm not doing that. My primary thing is just studying. So I'm sorry for the audio issue, but when I didn't have audio, I was making good progress. So I'm not going to go back and edit that or do anything about that. That portion of the video is just lost to time. But let's continue on now. Now, this is able to be heard. So let's. So this is going to be exactly the same. We're going to try matching the MAC. There we go. Don't get an error message or anything because it's matching. It should be able to detect that through the VSX link or what have you. Um, okay, so the next step is going to be OSPF. Let's skip it for OSPF version 2. I think version 3 will take care of it, but we'll be able to tell right away, pretty much, I think. So we'll do router OSPF v3 1 distribute connected area 0.0.0.0. Okay, so next step is to create the loopback interface and enable OSPF version 2. I think I'm going to skip that as well because we're only doing version 3. Um, so, yeah. Okay. So unfortunately, it looks like I only have IP OSPF here. Now I don't know if that's version 1 or version 3. Let's see here. Now it should say if it's version 2, not version 1. There is no version 1 as far as I know. Or if there is, it's been obsoleted by version 2. Uh, so now we should get a error message that version 2 has not been configured. And we did. OSPF process does not exist. Do we want to create it? No, we don't want to create it. Let's remove the version 2 instance, or sorry, the version 3 instance. There we go. And we'll remove it on both sides. Okay, that looks good. And then we'll also, and now we'll create a version uh, 2 instance of OSPF v3. Okay, so the proof is in the pudding now. I definitely, now I've got to update my beliefs here, make sure I'm not continuing to say that I believe that OSPF v3 is backwards compatible because I don't believe it anymore. We can see we've got a separate uh, RFC for version 4 as we do for version 3. So we can see the name of the RFC is actually um, let's see here. So so it's a different RFC. What the heck? Let me see if I can get OSPF v2 RFC. Okay, so these are not. Okay, so yeah, I no longer believe that um, OSPF version 3 is backwards compatible with IPv4 unless there's some special um, kind of wizardry. Yeah, so OSPF for IPv4 is version 2, for IPv6 is version 3. They don't interoperate, so that's one thing to consider when using OSPF. Am I going to be using IPv4 and IPv6? Perhaps there's something that makes it easier to use those in tandem than OSPF because that requires two separate protocols, essentially, version 2 and version 3 of OSPF. Okay, but I'm absolutely convinced now. I am updating my beliefs to believe that OSPF version 3 is not compatible with version 4, and you need to use version 2 for, sorry, with IPv4, and you need to use version 2 if you have IPv4 addresses, and version 3 if you have IPv6 addresses. And we see that here in the guide. This is evident of that. This is evidence for that. You can see we have IPv6, we have IPv4, and we have two instances of OSPF version 2 and version 3 because we've got both of those things. But in my lab here, I'm only using version 4, so I will only of IP, so I will only create the version 2 of OSPF instance. Okay, so I was wrong about that. The other thing I would like to do, and I'm not sure exactly how to do this, something called um, yeah, updating your priors. I'm interested in like thinking correctly, and I think oh, there's a T-shirt. I love that. I want that T-shirt. But this looks like a good site here. I think like Socrates. So okay, so the focus should be less about finding the absolute answer and more about establishing a reasonable range of probabilities. This recognizes the inherent volatility and variability that exists around us. Based on incremental evidence, update the solution set, narrowing or broadening your error functions, or in some cases, even overhauling the inputs. This has to be done iteratively at certain predetermined intervals, or even better, every time you have updated information. So here's why I thought to Google updating my priors because I have updated information now. I believe that IPv3 is not compatible with, or sorry, uh, OSPF version 3 is not backwards compatible with IPv4. So I want to update my priors, kind of why I believed that. And I think a big reason why I believed that is there was just holes in my gaps. I mean, I'll be honest. A lot of my goals early in my career were to get certifications and not necessarily to um, stray from the curriculum. Certainly not. That would have been absolute uh, not thing to not go very deep into the historical context, to not kind of get a sense of who the people are creating this. So really, when it came to my earlier priorities in my career, it was all about um, certification, and I'm kind of going a bit beyond that now. So I think one of the reasons I might have gotten this incorrect is just some aspects of only focusing on certification. Just don't, just kind of learning random facts is quite a bit different than having a context precedent for things, and that's what I'm trying to do now. So yeah, maybe this doesn't have to do with anything. Um, so I think this is a little bit unrelated because really I'm not doing any of this. I'm not making hypotheses. I'm not observing anything. I'm not um, considering a probability. I mean, honestly, I think the probability was 100%, but I really didn't have uh, a strong enough observation. So, really, I think, yeah, so update the priors as more data rolls in. Yeah, I'm not sure how I can apply that, but I just wanted to make sure that um, that was um, that was known because uh, oh my God. Yeah, I don't see any shirt that says update your priors, but I mean, this just sounds useful because I want to, like I said, one of the things I'm interested in as a hobby is, I'm the kind of person who kind of stresses over whether or not I made a good decision. So there are tools that can alleviate that stress and actually guarantee that you did the best you possibly could with the information you had at the time. And that is something I'm interested in. Okay, so let's continue on here. Next step is going to be a loopback interface. I'm not sure what this is for. Perhaps it's for the router ID. It might be mandatory. It looks like it's in the guide here. So let's, um, you know what? Let's leave that off and see if we have an OSPF neighbor. If we do, we don't need it. Okay, so we didn't find any OSPF neighbors. So let's try creating a loopback with an address and um, oh, you know what? We're actually not going to have a neighborship yet because we only did VLAN 30. So we're going to have to do VLAN 40 as well. Yeah, and then VLAN 40 will have a neighborship. And it looks like I missed a step here. Or not? Where did I enable the neighbor? Huh. I guess I'm surprised there's not OSPF enabled on the SVI. Oh, okay. They want it enabled on the so they I think they do want it enabled on the SVI. It's just it's just a different setup here. They want it enabled where you have the uh, on the networks you want. Oh, you know what? Because we have this redistribute connected, we don't need to enable it on the interface. It'll just pull in uh, any connected prefix. Perfect. Okay. So let's do this for VLAN 40. Okay, and then on the other side as well. All right, so that looks good to me. Um, and again, we're still not going to have neighbors, OSPF neighbors, until we fix up those links. I believe maybe it could go over the VSX. So let's take a peek. Okay. Again, we found no neighbors. So that's okay. We won't have them yet. Um, that is totally fine. Okay, so this is using it as a distribution switch. Yep. So all right, so we're done with the Arubas being used as distribution switches. So let's take a look at what that's going to look like in the now. So now, instead of this kind of topology, we have it looking like this, with VLAN 30 here and VLAN 40 here, just like it is in the picture there. So I think I'm going to end the video here. It's a minute and 40 seconds. I want to go do something else. So that's it for this video. In the next video, we'll be configuring the access layer for this figure 16. And then after that, we'll configure uh, figure 17, and then we'll keep reading the rest of the guide. All right, so thanks for watching and see you in the next video.